Aloha and welcome to the final video in our application attacks series. In this video, we're going to be talking about directory traversal, API attacks, and SSL stripping. So we'll start off with a discussion of directory traversal. And directory traversal is referring to the tree that represents your file system, your directory, and it's the traversal of it, going up and down. So when we're talking about, let's say in Windows, you have the C drive, you have C://, and then you have a folder name, and then you have a / and then a folder name. Well, when we're using a web server, the web server has what we call a root directory. And that root directory is the root of all the files that are going to be used in that website. And what you need to make sure of is that you cannot escape that root directory. In other words, you can't use different manipulations to get into resources that you shouldn't have access to. So there's this concept of directory traversal, also called path traversal or backtracking. And we use different characters to do things. Since we have this .. call that allows us to go up one directory level. So let's say your root is C:// inetpub /www root. That's where it defaults to when you're using the Internet Information Server on a Windows server. Well, if you were to try to use that C /inetpub /www root, then /.. it's attempting to go one directory up from www root, which it shouldn't have access to. So IIS is good. It does allow you to shut down behaviors like that, but some types of web servers may not check for that. They may allow you to escape your root in that sense. They may allow you to do things like, request files that are outside the directory structure that you're supposed to be, kept to. Also within programs, if you try to access files that are outside of the web server's, area, you may run into trouble. If you're given access to files that are outside of that, that could be problematic as well. So there's different things we do to mitigate this. Server settings are one thing, but there's another thing that you can do, and that is to make sure that you separate out your the files that the users will be accessing, the website files. You want to keep those on a separate disk or in a separate partition from the system directories that you have, because you don't want people being able to access particularly the executables from your system. Because once they can do that, they can probably find ways of getting more permission sets, escalating privileges, executing binaries that are in there. You don't want that kind of behavior. So you'll want to keep those separated. So you want your system disk separated from the rest of your web application. So that's one thing you can do. And you can also check settings to make sure that people can't traverse outside of their web root. So the next topic we're going to talk about is API, API attacks. So first of all, what is an API? An API is called an application programming interface. And that's how we get data out of other programs. So we can actually make calls using what we call API calls. And those are functions and protocols that build and integrate different applications with each other. So you can call on, let's say, Facebook and get information from Facebook, or you can call on, whatever application you have out there and use an API call to pull data out of it. So that's really cool. You can, for Google has a lot of different services out there, like Google Maps. You can go to Google Maps, use one of their APIs, and you can pull information out of their application. And that's just really neat and convenient. So that, of course, opens up another, attack vector. So API attack vector is one that exists. So API are a target of various attacks because APIs provide entry points into the application and enable access to the application's data. So this API attack, it's an attack that exploits the vulnerabilities in an application's API to attack the application or service. So the aim of the API attack is to disrupt the services or have it access data that it shouldn't be retrieving. So a good example of a DOS attack on one of these, a denial of service attack, is one where they just try to overload the system with requests until it shut down. So you can try to do denial of service attacks that way. But these APIs that you have out there, because they are pipelines into your data, you have to make sure that they're secure, and you have to make sure that they're not giving up any data. We also need to be careful because it can be used against you if you had a zombie botnet that just started pummeling it with all kinds of requests for data. So then we also have secure socket layer stripping, SSL stripping. So this is a type of downgrade attack, and a downgrade attack is an attack that attempts to shift client-server communication to a less secure encryption type. So secure, the SSL stripping, also called SSL downgrading or HTTP downgrading. It's a downgrade attack that aims to downgrade an attempted HTTPS connection between a web server and client to an HTTP unsecured connection. So unlike an HTTPS connection, the HTTP connection does not provide any data confidentiality, integrity, or authenticity. So SSL stripping, the type of on-path or man-in-the-middle attack. You need to have the attacker in the middle of the data stream, between the end user and the server to be successful at this. So what's going to happen in this, in SSL stripping, an attacker is going to intercept a web server's redirect response to a client's HTTP request. Usually when you go to a site and you just try to access it with normal HTTP, it tries to say, hey, that's great, but I want you to use the secure version, and it sends them to the HTTPS. Well, if you're in the middle of that, what you do is you intercept that, and then you establish the connection with the server, and then you basically hand everything back to the other side, to the client, with a regular HTTP. So he's going to be, so that user is going to connect with you unsecure on HTTP. Then you're going to do all the secure communications with the web server, modifying it as you want, as the in-between person, the man in the middle, or woman in the middle if you prefer. So that is the problem with this. So throughout the attack, the client is unknowingly communicating with the attacker via the HTTP connection, and the attacker communicates with the web server via the HTTPS connection. So this is a very bad situation. So another thing to keep in mind, cryptographic vulnerabilities. So cryptographic vulnerabilities, for example, the SSL stripping, they highlight the importance of implementing strong cryptographic measures to secure your online communications. The vulnerabilities, they arise from weaknesses in encryption algorithms, key management, protocol implementations, comprising the confidentiality, integrity, and authenticity, the CIA of sensitive data. So effective mitigation of these vulnerabilities requires establishing a secure cryptographic configuration, keeping software and protocols up to date, and implementing security best practices such as secure key exchange and authentication. Additionally, proactively identifying and remediating vulnerabilities such as weak keys or outdated encryption models is essential to preventing attacks that exploit these weaknesses. So that's it for this section as well as this chapter. If you have any questions about it, feel free to reach out. I'm always happy to answer. Aloha.